Dear students, in today's presentation, I'm going to explain the next chapter, chapter number 4, titled Motion in a Plane. Before learning about this particular chapter, first we need to understand certain terms like what is a scalar, what are the examples for scalar. We have already learned this definition earlier. A physical quantity having only magnitude is called a scalar. Examples are, all the fundamental quantities are example for the scalar, mass, length and time. So what is a scalar quantity? A quantity having only magnitude is called a scalar quantity. What is a vector? And what are the examples for vectors? A physical quantity having both magnitude and direction is called a vector. Examples are displacement, velocity, acceleration, force, momentum are the example. We represent a vector with the help of a straight line with an arrow. The length of the line indicates the magnitude of the vector, and the symbol used for that is a vector notation above a particular quantity. So here it indicates vector A acting along the right hand side direction. The next is vector B. Now you can see the magnitude of the vector B is lesser compared to that of vector A, but both acts along the same direction. Look at the vector C. Vector B and vector C, they have same magnitude, but they act in opposite direction. So this is how we represent any vector. Name the physical quantity which can be described by its magnitude, unit and direction. The question from 2016, and the answer to this question is vector. Is scalar multiplied by a vector gives a vector or a scalar? So go through the question again. The question is, there is a scalar, and when it is multiplied by a vector, do we get a vector quantity or a scalar quantity? Now that is the question. So that is a scalar. When multiplied by a vector, do we get a vector or a scalar? The answer to that is a vector. Example, when we multiply mass by acceleration, you will get force. Mass is a scalar. Acceleration is a vector quantity. And when you multiply a scalar and a vector, you will get a vector quantity, and in this case it is force. You all are familiar with the equation. F is equal to m into a. So that is how a scalar when multiplied by a vector gives a vector quantity. Distinguish between a scalar and a vector. What are the differences between scalars and vector? So important question. It has appeared twice in the examination. And there are two differences that we can write for scalars and vector. One of the difference is the definition itself. A physical quantity having only magnitude is called a scalar, whereas a physical quantity having both magnitude and direction is called a vector quantity. The second difference, when we multiply two scalars, we get a scalar quantity. When we multiply two scalars, we always get a scalar quantity. Whereas, when we multiply two vectors, we may get either a scalar or a vector. When we multiply two vectors, we may get either a scalar or a vector. So example for that we are going to learn later in detail. So for timing, you remember these are two differences. Important question. What is a null vector? The meaning of the word null means nothing, zero, or nil. So, a vector whose magnitude is zero is called a null vector or a zero vector. For example, if the net force is zero, then we can call that as a null vector. If the net acceleration is zero, then we can call it as a null vector. And magnitude we represent by drawing a vector within two vertical lines. We read it as modulus. So modulus of the vector here, if it is equal to 0, then we can call this vector as a null vector or a zero vector. What is a unit vector? So you can see this question has appeared 4 times in the examination. Unit, unity means 1. So a vector whose magnitude is 1 is called a unit vector. So what is a unit vector? A vector whose magnitude is 1 or unity is called unit vector. This unit vector is represented by a symbol which is A with a cap above, cap, hat. So this is a vector symbol. This is also a vector, but this is exclusively used for unit vectors only. And you can see magnitude of the unit vector is always is equal to 1. So that is how we represent a unit vector. Give the mathematical representation of a unit vector. So how mathematically we can measure a unit vector? A unit vector is defined as the ratio of the given vector to its magnitude. If you take any vector and if you divide by its magnitude, you will always get a unit vector. This is how mathematically one can find the unit vector. And this is the notation which is used for the unit vectors. What are equal vectors? Vectors having same magnitude and same directions are called equal vectors. You take vector A acting towards the right. You take one more vector having same magnitude acting along the same direction. Now these two vectors can be called as equal vectors. Here you can see the magnitudes are same. The direction is also same. So that's why they are called equal vectors. What is a negative vector? Two vectors of equal magnitudes but in opposite directions are called negative vectors. So take one vector having magnitude A acts towards the right. Now we take one more vector having the same magnitude but acts in the opposite direction. Then one is taken as positive, other is taken as a negative vector. If we take this vector as positive, then this is to be taken as negative. So vectors having same magnitude but acting in opposite directions are called negative vectors. What are parallel vectors? Vectors whose line of action are parallel to each other are called parallel vectors. Again, example will make things clear. So one vector, which is A, you take one more vector having same magnitude, but they are parallel to each other. This is called line of action. This is the line of action. For this is the line of action. And if the line of actions are parallel, then we call them as parallel vectors. And parallel vectors acting along the same directions are called like parallel vectors. And parallel vectors acting in the opposite direction, they are called unlike parallel vectors. What is a resultant vector? We can always add identical vectors. Minimum number of vectors required for addition is 2 and maximum any number of vectors can be added. And after adding all that vectors, we get one single vector, and that single vector is called the resultant vector. So resultant vector is that single vector which produces the same effect as the individual vectors acting together. So you take one vector, vector P. You take one more vector Q, and when you add, you will get a third vector, and the third vector is called the resultant of the first two. So therefore here, when you add two vectors P and Q, you are going to get the third vector R. So R is called the resultant of the vector P and Q. To add two vectors, we have two important laws. The first law is called as a triangle law of vector addition. So as the title suggests, we need to construct a triangle to find the resultant. So these laws are used to find or to locate the resultant of two vectors. So this question has appeared twice in the examination, and the statement goes like this. If two vectors acting at a point can be represented by the two sides of the triangle taken in order, then the resultant is represented by the third side of the triangle taken in opposite order. So to understand this, let's take a vector. So this is the vector, and I'm going to construct a triangle with the help of this vector. I'm going to consider this as one side of the triangle. I'm going to consider one more vector q, and this is the vector to be added. The vector p and q to be added. So with the help of q, without changing the direction and without changing the magnitude, you take the next side, the second side of the triangle taken in same order. Taken in same order. You can see here, this is the order in which they are taken. Both the vectors are taken along the anti-clockwise direction. So that is the meaning of taken in same order. Then the resultant is represented by the third side of the triangle taken in opposite order. So if we construct the third side comes here. See, that will give you the resultant of the first two vector, and then you can see it's taken in opposite order. That means this arrow is taken here in this direction, which is a clockwise direction. So with the help of two sides, so go through the vectors. So this is one of the vector. Construct one side called P. Then take the second vector to be added, and you place that in such a way that both the vectors are in same order. So you can see the magnitude and direction of q remains the same as the given vector. And now by closing the third side, that will give you the resultant of both p and q. And we know that the resultant acts here, exactly in between. See, this is how we get the resultant. This is the direction along which we get the resultant, and that's evident in this particular diagram. So the statement is, if two vectors acting at a point can be represented by the two sides of a triangle taken in order, then their resultant is represented by the third side of the triangle taken in opposite order. So this law is used to find the resultant of two vectors, and this law is called the law of triangle of vector addition. There is one more law which is also used to find the resultant of two vectors, and that law is called the parallelogram law of vector addition. Question again from one of the exam. So what is the statement of this law? If two vectors acting at a point can be represented by the adjacent side of a parallelogram drawn from a point, then their resultant is represented by the diagonal of the parallelogram drawn from the same point. In the previous law, we have constructed a triangle, and now here with the help of the two vectors, we have to construct a parallelogram. So first let's consider a vector, and with the help of this, I'm going to consider one side of the parallelogram. Then I will take the second vector to be added, so that's a vector q. And with the help of this, you construct a parallelogram. So this is how we construct a parallelogram. So first take vector p, and then take the vector q, and then construct a parallelogram. And then the law states that the resultant is represented by the diagonal of the parallelogram drawn from the same point. You can see the vectors are drawn from here, so therefore the diagonal is also drawn from the same point, and that diagonal drawn from the same point gives the resultant of the two vectors. So go through the statement once again. If two vectors acting at a point can be represented by the two adjacent sides of a parallelogram drawn from a point, then their resultant is represented by the diagonal of the parallelogram drawn from the same point. So as you have noticed, whether it is a triangle law of vector addition or parallelogram law of vector addition, we get the same direction of the resultant. In the previous as well as here, the direction of the resultant remains the same. It is here only. Even in the previous case, we got the resultant here. Now, even when we have used the parallelogram law of vector addition, we are getting the same position of the resultant. So, hope you have understood the basics of the vectors. So, we are going to learn more about this vectors, and then we'll come back to the actual chapter, which is motion in a plane. So, I'm going to continue the rest of the topics in the next class. So, till then, take good care of yourself. Thank you.